Hello everyone and welcome back. In this video, we will be learning about the additional relational algebra operations. Some database requests specified by the database users cannot be performed with the original relational algebra operations which we have learned in our earlier videos. That is, those requests cannot be performed with the unary, set theory or the binary relational algebra operations. So for that we have the additional operations to perform these requests. Let us learn each of them. The first is the aggregate functions denoted by this symbol which is pronounced as script F. There is no particular agreed notation for aggregate function. Sometimes script A symbol is also used to represent it. Now along with this aggregate function, we will also learn about grouping. The first type of database request that cannot be performed with the basic or the fundamental relational operations is specifying aggregate functions on the values in the database. Common types of aggregate functions that we use on the numerical values in the database are sum, average, maximum, and minimum. We also use count function to count the tuples or the values. There is also another type of database request where we require grouping of the tuples or rows in a relation and then applying the aggregate function on each group. We will learn this with the help of examples. Now the syntax of aggregate function is grouping attributes in the subscript followed by the aggregate function symbol followed by the function list again in the subscript and then followed by the relation name on which we want to perform the aggregate function. Here the grouping attributes are the list of attributes in this relation R, and function list is a list of aggregate function and attribute pairs. These grouping attributes are not mandatory and we can apply aggregate function even without these grouping attributes. With examples you will understand this better. Let us discuss the first example. Here I am taking an employee relation with first name, SSN, salary and department number as its attributes. And from this relation, I want to retrieve the number of employees and their average salary. Here we just need the number of the employees and their average salary. So we do not need to group by any attribute. We can directly apply the aggregate function. Hence, it would be represented this way, aggregate function symbol followed by the function list, that is the function name and the attribute pair, and then followed by the relation name on which we want to perform this aggregate function. Here, since we need the number of employees, we use the count function. SSN or the social security number is the attribute by which we identify each employee uniquely, similar to the roll number of the students in a class. Next, we need the average salary of all the employees. Therefore, we use the average function on the salary attribute. Hope you understood how to write the query using the aggregate function. Let us now see the result of this query. So, count SSN will count the number of SSNs in this relation employee. We see that the count of SSN is 4 in this relation. The next function is average on the salary attribute. So the average of the salaries of all the employees are calculated. We know how average is calculated, that is 40,000 plus 30,000 plus 30,000 plus 20,000 divided by 4, which is equal to 30,000. Hence, this would be your result. When the attribute names of the resulting relation is not mentioned explicitly in the query, then in the result, the attribute name would be function name followed by an underscore and then followed by the attribute name on which we perform the function. Let us see another example. Here we need to retrieve the number of employees and their average salary in each department. In this relation employee, we have two departments, that is department number 1 and department number 2. We need to count the number of employees in each department and also their average salary. Since we need the result by each department, we need to group by department. So in this relation employee, the attribute that contains information about the department is D number. So this is the grouping attribute. Let us see how to write the query. First, we mention the grouping attribute, that is dNumber, followed by the aggregate function symbol, and then followed by the function list, that is count of SSN for the number of employees and their average salary from the relation employee. Now this would be the result of the query. First, it groups by department number 2, and then the number of SSN is counted in this department. We see that in this department number 2, the count of SSN is 3. Also, the average salary of all the employees in department number 2 is calculated. That is 40,000 plus 30,000 plus 20,000 divided by 3, which is equal to 30,000. Hence our first tuple. Next, it groups by department number 1. In this department, the count of SSN is only 1 and the average salary will be 30,000. Hence the second tuple. Here dNumber is the grouping attribute. Count SSN is the function performed on this attribute SSN, and average salary is average function performed on the salary attribute. Now if we want to rename these attributes, we can do it by writing the query this way by using the rename operator before the grouping attribute. We have already learned how to use the rename operator in one of our earlier videos. So we use the rename operator followed by the new relation name in the subscript, followed by the name of the attributes that we want in the resulting relation. The rest of the syntax remains the same. We get the same result with the relation name as mentioned here and also the new attribute names as mentioned with the rename operator. This is all about the aggregate functions. They perform certain functions on a set of values and returns a single value. Next, let us learn about recursive closure operations. Another type of operation that cannot be specified in the basic relational algebra operations is the recursive closure operation. As the name itself suggests, this operation is applied to a recursive relationship. We have already learned about recursive relationships with an example in one of the previous videos in the ER model or the entity relationship model chapter. Let us see an example. Here I am taking a relation employee with first name, last name, SSN and super SSN as its attributes. Here super SSN is the SSN of all the employees supervisor. So this is the list of all the supervisors. Now I want to retrieve the SSN of all the employees directly supervised by Elsa David, that is at level 1. So these are the steps involved to get the SSN of all the employees supervised directly by Elsa David. Let us see these steps one by one. Taking the first step. In this step, first we need to select the tuple with F name as Elsa and L name as David from this relation employee. And then from the selected tuple, we project only the SSN of the employee and store it in this relation. So as discussed, first the tuple with F name as Elsa and L name as David is selected, and then from this selected tuple, only the SSN is displayed or projected, and its result is stored in Elsa SSN. So this relation contains the SSN of the supervisor Elsa David. Moving on to the second step, here we are projecting the SSN and super SSN of all the employees from the employee relation, and we are storing its result in a relation called supervision with its attributes mentioned explicitly SSN1 and SSN2. Since we want to know which employee is under Elsa David, we project their super SSN or the supervisor SSN of each employee to match with the SSN of Elsa David. Therefore, the result will be projection of SSN and super SSN of all the employees from the employee relation into the supervision relation with attribute names SSN1 and SSN2. Now moving on to the last step of this query, we need to join two relations, the supervision relation and the Elsa SSN relation. We know that the relation supervision contains the SSN of all the employees and also the SSN of their supervisors. And the relation Elsa SSN contains the SSN of the employee Elsa David. Now we need to check if Elsa David is a supervisor of any employee. For that, we need to join these two relations by a join condition. That is, we need to check if the SSN of Elsa David matches with any of the SSN of the supervisors, which means that SSN2 should be equal to SSN and hence the join condition. First, let us see the result of this join operation. We have already seen how join operation works. So when we join these two relations, the supervision relation and Elsa SSN, we see that there are only two tuples that satisfy the given join condition. So the combination of these tuples will be displayed in the result of the join operation. Now from the result of the join operation, we project or display the SSN1, which is the SSN of the employee, and store its result in the relation result1 with its attribute name mentioned explicitly. So these are the SSN of all the employees directly supervised by Elsa David. Now with the same employee relation, let us see an example to retrieve the SSN of all employees supervised by Elsa David at level 2. That is, we need to retrieve the SSN of all the employees who are supervised by a supervisor, and that supervisor is in turn supervised directly by Elsa David. Hope you understood the question. You will understand it better once we discuss the query. This is the query to retrieve the SSN of all the employees supervised by Elsa David at level 2. Let us see how this works. As already seen, the supervision relation contains the SSN of all the employees and their supervisors, and result 1 contains the SSN of all the employees directly supervised by Elsa David. Since we need to find out the employees who are supervised by these employees directly under Elsa David, we need to join these two relations with a join condition. That is, we need to check if SSN2 is equal to SSN. We see that there is only one tuple that satisfies a given condition. So that combination of the tuple is the result of the join operation. From the result of the join operation, we need to project or display the SSN1 and store its result in a relation result2. So this is the SSN of the employee who is supervised by the employee with SSN 1, 2, 3, 6, 5, 4, 7, 8, 9, and this employee in turn is directly supervised by Elsa David. Therefore, this is the only employee who is supervised by Elsa David at level 2. Hope you understood the two examples that we just discussed. Now, if I want to retrieve the SSN of all the employees supervised by Elsa David, both at level 1 and level 2, what do I have to do? I already have the SSN of all the employees directly supervised by Elsa David, that is at level 1. Also, I have the SSN of all employees supervised by Elsa David at level 2. I just have to perform a union of these two results. And its result is stored in this relation, which will contain the SSN of all the employees supervised by Elsa David, both at level 1 and level 2. That's it about recursive closure operations. Hope you have understood them. Next, we are going to learn about outer join operations. In our previous video, we had learned about a join operation. That join operation which we learned displays in the output only those combination of tuples from the two relations that satisfies the given join condition, and tuples that do not match are eliminated or they are not displayed in the result. This leads to loss of information. Now, to overcome this limitation, there is another set of operations called the outer join that can be used when we want all the tuples from relation R, or all the tuples from relation S, or all tuples from both relation R and S to be displayed in the result, even if the tuples do not match. This avoids loss of information. The join operation which we learned earlier, where only the matching tuples are displayed, is called inner join. Hope you understood the difference between outer and inner join. Now there are three types of outer join operations. The first is the left outer join. The left outer join operation keeps all the tuples from the left relation and only the matched tuples from the relation on the right. This is an example query for left outer join, and left outer join is represented using this symbol. This is the same symbol that we use for inner join, just that for left outer join we have two lines protruding on the left side of the symbol. I've taken a very simple example over here where I'm performing a left outer join on two relations, relation R and relation S by a condition. Here I've taken relation R with attributes A and B and relation S with attributes C and D. As already discussed, when I perform a left outer join on these two relations, relation R and relation S, with a condition A is equal to C, all the attributes from the left relation is displayed in the result. And from the right relation, that is relation S, only those tuples that satisfy the given condition is displayed. The tuples that do not satisfy the given condition are padded or filled with null values. This is the result of the left outer join. Let us see how it works. As I mentioned earlier, all the tuples from relation R will be displayed in the result, regardless of whether it satisfies the given condition or not. And from the right relation or relation S, only those tuples that match the given condition is displayed, rest are filled with null values. So here we see there is only one tuple that matches the given condition, so that tuple will be displayed in the result. This tuple did not satisfy the given condition, hence instead of these values, they are filled with null values. Hope you understood how left outer join works. The next type of outer join is the right outer join. This operation is the exact opposite of left outer join. That is, it keeps all the tuples from the right relation and only the matching tuples from the left relation. Let us take the same example. This is how we write the query for right outer join, where right outer join is represented using this symbol. Here the two lines are protruding on the right side of the symbol. This is the result for right outer join. Let us see how this works. As mentioned, all the tuples from the right relation is displayed in the result, regardless of whether it satisfies the condition or not. But from the left relation, only the matched tuples will be displayed in the result. The rest will be filled or padded with null values. So here we see that there is only one tuple that satisfies the condition, so that tuple will be displayed in the output. This tuple does not satisfy the given join condition, hence it will not be displayed in the result. Instead, it will be filled or padded with null values. So that's about the second type of outer join, the right outer join. Finally, we have the full outer join. This operation keeps all the tuples from both the relations, and those tuples that do not satisfy the given condition are filled with null values. This is how we write a query for full outer join. And full outer join is represented using this symbol where the two lines are protruding from both the sides of the symbol. This is the result of full outer join, and let us see how it works. We already mentioned that all the tuples from both the relations will be displayed in the result, and where the tuples do not match, it will be filled with null values. So here we see that the first tuple satisfies the given condition. Therefore, both those tuples from relation R and relation S will be displayed in the result. The next tuple from relation R does not satisfy the condition A is equal to C. That is, this number 2 does not match with any of these values. Therefore, that tuple will be displayed in the result, and since there is no matching tuple from relation S, it is padded with null values. Similarly, this tuple from relation S does not satisfy the given condition, that is, there is no value 3 to match from relation R. Therefore, this tuple will be displayed in the result. Also, since this tuple does not have any matching tuple from relation R, those values are filled with null values. And that is it about the full outer join. Hope you understood the 3 outer join operations. The last topic under additional relational operation is the outer union operation. We have already learned about union operation in our lecture on set theory relational algebra operations. In that lecture, we had discussed that to perform a union of two relations, those two relations have to be union compatible. That is, the two relations should have the same degree or the same number of attributes, and also their domains should be the same. That is, they should have the same data type. Now, there could be cases when a union of tuples from two relations are required, but the two relations are not union compatible or they are partially compatible. That is, only some of the attributes are union compatible. In such cases, we perform the outer union operation. Let me take a simple example to show you how this operation works. Here I'm taking a relation R with attributes A and B and relation S with attributes A and D. We see that these two relations are partially compatible because they have the same number of attributes. Relation R is of degree 2 or it has 2 attributes. Also, relation S is of degree 2. Therefore, that condition of union compatibility is satisfied, that is, they have the same degree. But we say that the domains of the attributes are not the same. The data type of these two attributes match, but the data types of B and D do not match. Hence, the second condition of union compatibility is not satisfied. Therefore, these two relations are partially compatible. This is the result of the outer union operation. Let us see how it works. We see in these two relations there is a common attribute, that is attribute A. Now from the first tuple from relation R, this value matches with this value. Therefore, these tuples are displayed in the result. Similarly, the second tuple from relation R is displayed in the result. Since this value 2 from relation R does not match with any of the values in this common attribute from relation S, the remaining tuple will be filled with null values. Similarly, the value in this common attribute does not match with any of the values in the common attributes from relation R. Therefore, in the resulting relation, A and D is filled with these two values and the remaining is filled with null values. Hope you have understood the outer union operation. With this, we come to the end of this video. In this video, we discuss the additional relational algebra operations. That is the aggregate function, recursive closure operation, outer join operation, and the outer union operation. Hope you have understood them. Thank you.